Hey everyone, so I just wanted to take a quick look at thermistors and temperature sensors in general, and to just clarify something that I wish I knew when I first started learning about temperature sensors and trying to use them. And they're actually fairly simple devices. They so basically a temperature sensor is you know just a device that convert that helps you to convert the temperature of something into some form of electrical signal that can be translated into degrees Celsius or degrees Fahrenheit or any other unit such as Kelvin. So this is a little bag of thermistors that I purchased, but I'm not going to bother to open that bag. I have some loose thermistors here. Let me just grab one. Right, so I'm just trying to focus here. Okay, this isn't so easy. Alright, so this one is very tiny, so that makes it hard to focus. Um, Cheap camera doesn't help. Right, so the a thermistor um is often a part of a temperature sensor, or actually, generally, it usually is. Um, Pretty much everyone I've seen, although there might be other types that I'm unaware of. So this is actually a thermistor is actually a resistor, a temperature sensitive resistor. So it may either increase its resistance value as temperature increases, or it might decrease its resistance value if temperature decreases. But there's also that's called a positive temperature coefficient thermistor, but this one I'm holding here is actually a negative temperature coefficient thermistor, or NTC. So what an NTC does is its resistance inversely follows temperature. So if the temperature increases, the resistance of this one actually decreases, right? So manufacturers build both of them, so you'll have a choice, and you know whichever one is more suitable for you is simply dependent on how your project is designed. So it's really about convenience. So you don't really need to worry about if a PTC or NTC is better. They're not really better than each other. It's just a matter of choosing what suits your project best. Right, so this tiny little bulb is made of. I'm not even going to get into that, but it's a terribly simple device. It has pins, two leads rather, and you hook it up just like you can hook it up to a multimeter, like a resistor, and set the multimeter to the resistance setting, and you'll actually be able to see how much what the resistance is, and you can actually use it to calculate the temperature. Right? So there are various values that may come with a thermistor. Yes, I'm trying to remember them. May have to post that in the description. Right? And then those values help you to convert the resistance into degrees Celsius or degrees Fahrenheit. So the unfortunate problem with these thermistors, I'm not going to mention the brand. I don't even remember what it is. But it was a very cheap brand that I bought because they were offering like 50 of them for $8 or something like that. So I couldn't resist. Anyway, they are so that means is that I had to try and do various tests and try to guess what the resistance would be at each temperature, and to keep making a note of resistance at each temperature until I was able to calculate exactly what the ratio of temperature to resistance would be, or what something along those lines. So whenever you're purchasing a thermistor, ensure that the manufacturer is providing you with the values that are required to. God, these are very important. What's it called now? A very important figure. Right, so the figure is called what I was referring to was a Steinhart equation. My apologies for struggling to remember it a while ago. So that equation is something that helps you to determine what the temperature is based on the resistance. So that's not something that I can explain to you now. However, if you don't want to have to put up with that, you can actually purchase a digital temperature sensor, which is a nicely packaged IC containing a thermistor and the necessary electronics to measure and calculate what the temperature is. So those devices could, for example, transmit an actual temperature reading instead of a resistance or voltage via I2C to your microcontroller or your Raspberry Pi. So that's actually far easier to use, and that way you won't have to worry as much about accuracy, about making mistakes and determining its accuracy, because you won't have to work with an analog to digital converter. So if you're to use these thermistors, which are far cheaper than digital temperature sensors, by the way, you would have to carefully hook them up to an analog to digital converter. Many microcontrollers do have these, and it did build a what's it called now, a motor controlling thermostat using one of these thermistors once. I hooked it up to a Texas Instruments microcontroller and use it to sense basically set it up so that the microcontroller would convert the voltage resulting from the resistance caused by the thermistor into a temperature in degrees Celsius, and then I use that to control the PWM duty cycle. So I was able to vary the speed of a fan motor precisely according to the temperature. So again, that is a fun project if you want to get into that and learn about it. And actually published a video of that project on this channel a while back. So yeah, that's pretty much it. So a temperature sensor is a transducer, and they're easier to use temperature sensors that cost you more, and they're also the more complex ones, which could also give you more granular control of what you're doing, I suppose, like thermistors. But just bear in mind that the relationship between temperature and resistance in a thermistor is not entirely linear. So what that means is that the increase or decrease in resistance in relation to temperature is not per degree Celsius, is not consistent. So you might find that the thermistor behaves very differently once it gets below a certain temperature, or it behaves very differently once it gets above a certain temperature, even if those temperatures are well within the manufacturer's specifications. So that's another thing that you're going to have to worry about. So that's another reason to buy digital temperature sensors. So yeah, that's pretty much it. If you have any questions, feel free to ask them in the comment section, and thanks for watching.